Alright, hello everyone. We left off on the last video with the heating curve of water. We do go on from this a little bit more. I know this is where the notes basically end, but we do have a couple more notes to take off to the side of your packet. So let's continue. Intermolecular forces are the forces between the particles or the molecules in a given substance. The closer these particles are to each other, the stronger the force will be between them. So in solids, the intermolecular forces are pretty strong, which is why the particles here are able to stay close together and have a fixed volume and shape. In liquids, they're a little bit weaker, which is why liquids are able to flow and move a little more independently of each other. One drop of liquid could move and the other one could stay put in the same substance. That is because the forces between them are a little bit less strong than they are on solids. And with gas, it's even less. So it's basically zero force between them. They are able to break free from these intermolecular forces, which is why they're able to fly off from one another and these particles bounce all around the given area that the gas is in without having to interact with one another as much. So we finished concept 3 now. I hope you were able to copy this next to your notes of concept 3. If you're looking for where to put it, just off to the side in the Cornell note style, you have some blank space off to the right. You could just go ahead and copy this slide there. If you need to pause here and copy that, feel free to do so. Alright, are you ready to move on? Let's go back to concept 1 for a short second. So let's go back to page 3. And we left off with heterogeneous and homogeneous mixtures. Remember, homogeneous, everything is very seamless. You can't distinguish the parts of the mixture from one another. In heterogeneous, you can. And there are two specific kinds that we are going to touch on today. The first is a colloid, which are very small particles that are dispersed evenly throughout the entire mixture or solution. They are larger particles than would be in a normal solution. So if you have a solution like Kool-Aid in water, those particles are so small they dissolve in the liquid. So they would be a homogeneous mixture. However, with colloids, these particles are slightly larger than solution particles, but they are still small enough to where it looks like an even distribution throughout. Think of, for example, dusty air. There's wind storms that can have a lot of sand or dust in the air. And those are small particles and they are evenly spread throughout the air, making that a colloid heterogeneous mixture. The other type we have is suspension. These are larger particles that look to be uniformly distributed, but over time they're going to settle out into two different layers. Similar to oil and water. When you first drop the oil in water, you see these bubble-like things cast within the water, and then eventually, if you let it sit for long enough, it'll become its own separate layer. Usually, people can confuse colloids and suspensions with solutions. Remember, solutions are homogeneous. They are not heterogeneous. Alright? Colloids and suspensions are not solutions. I repeat, colloids and suspensions are not solutions. They can look to be similar, but the particles are larger than those in solutions. Alright? Lastly, the Tyndall effect. This is what happens when light scatters through a mixture. So this only happens with colloids and suspensions where the particles are large enough where they will block parts of the radiation that's trying to go through the mixture. So these particles will scatter the light, making these like ray looking things happen. So think of like when the light goes through trees and that scattering of the light, that's similar to what happens when you shine a light through a beaker or a glass that has a colloid or a suspension in it. The light will scatter just like this. And that's it. I hope you are ready for your test, your Unit 1 quiz. Please study, and I will see you in class. Have a great rest of your day. Bye.